Okay, hi guys. We shall analyze system for its stability in this video, and we'll take a few examples on it. Okay, uh, let our first system be y of t is equal to x square of t. It's a system. For every input I feed, output is its amplitude is getting squared, right? Okay. So solution. So what's the definition of stability of a system? For every bounded input, I should get bounded output. Then only I call it as that system is stable, right? Uh, let let the x of t input to the system. So I have a system here, t x of t, and whatever the input I am feeding to the system, I am assuming that it's bounded. Okay, so let magnitude of x of t is less than or equal to some value, finite value bx. It's a bounded value and of the input signal x of t, and this bx is less than infinity. Let we apply the bounded input signal to our system. And what is the system? It is this. So it is squaring the amplitude of the signal. Okay, fine. Then what is output from the system? Magnitude of y of t should be, what is the condition actually? This should also be bounded. Output from the system should also be bounded, right? And what is y of t? Y of t is a square of t, right? Which is equal to magnitude of x square of t. Magnitude of y of t is nothing but magnitude of x square of t. Why? Because y of t is x square of t, right? And is this bounded? I mean, x square of t is bounded. For example, if I give amplitude of the input signal as 10, what is the output from the system? It is 10 square, right? If I give 100, 100 square, which is bounded, right? If I give 1000, 1000 square, which is also bounded. Okay, but I cannot give infinity to the input. Why? Because I am assuming that it is bounded. It is always finite. The input signal which I am feeding to the system is always bounded. So for every bounded amplitude I give to the system, output is also bounded. It is squaring that amplitude, right? Correct now? So shall we assume that, shall we claim that the output from the system is bounded, right? So for every bounded input, I am getting bounded output, right? So which is which is less than or equal to by, and this by is less than infinity, right? Magnitude of y of t, which is magnitude of x square of t, is always less than or equal to by in this system, and that by is less than infinity, right? So therefore system is stable. Why stable? Because for every bounded input, comma, we get bounded output. Okay, we'll take up one more. Let me just take up here. So y of t is equal to x of 2t. So this is our system. Okay, so solution. So I have a system which does the transformation, and I get the output y of t, and I'm feeding x of t, and I get y of t. And what is y of t? Y of t is x of 2t. So same thing, we'll assume that the input what we are feeding to the system is bounded. So let magnitude of x of t is less than or equal to bx, which is less than infinity. Then magnitude of y of t, which is equal to, what is y of t? Magnitude of x of 2t. And what is your claim? Is this bounded? Is this less than or equal to by? So what is system doing? If I feed x of t to the system, what is the output I'm getting? X of 2t. Does it changing anything to the amplitude of the input signal? Right? If the amplitude is 1, output is also 1. If the amplitude is 2, output is also 2. If amplitude is 100, output amplitude is also 100. It doesn't doing anything to the amplitude, but it is doing something to the time, but we are not bothered about the time. To analyze the system stability, we have to concentrate only what's happening to the amplitude of the system. Okay, so this is actually by, right? Is always less than or equal to by, and which is less than infinity. So for every bounded input I apply, I am getting bounded output, right? I can write this as bx also, because the input and output both are same, but we'll stick on to the definition. This is actually less than or equal to by, which is less than, right? So for every bounded input I am getting bounded output. So therefore system is stable. Why? For every bounded input I am getting bounded output. Okay, we'll take up one more. Y of t is equal to x of t by 2. Okay, solution. So we'll assume that let magnitude of x of t, the input what we are feeding to the system, is bounded by a value of bx, and that value is less than infinity. So then magnitude of y of t, which is equal to magnitude of x of t by 2, is less than or equal to, so what do you say? Is this bounded? Yes, right? Why? Because, so x of t, if I apply, what is y of t? Y of t is what? X of t by 2. Does it doing anything to the amplitude of the input signal? No, right? What it is actually doing something to the time, but we are not bothered about time. So whatever the input signal I feed, the same amplitude I get across the output also. So for every bounded input I get bounded output. So this is actually less than or equal to by, which is less than infinity. So for every bounded input I get bounded output. Therefore system is stable.